Have you ever wondered what it would be like to mine an asteroid? An intriguing thought, isn't it? Welcome to the fascinating world of space mining, where the future of resource extraction might just be written in the stars. Space mining, as the term suggests, revolves around the extraction of rare minerals and other valuable resources from asteroids and other celestial bodies. This concept, once the stuff of science fiction, is now becoming a topic of real-world discussions and research. Why the sudden interest, you may ask? Well, our home planet isn't exactly infinite when it comes to resources. We have been digging deep into the Earth's crust for centuries, mining for precious metals, fossil fuels, and other commodities that fuel our modern lives. But these resources are dwindling, and the environmental impact of our extraction methods is becoming increasingly clear. Enter space mining, a potential solution to both these problems. Picture this: an asteroid orbiting peacefully in the vast expanse of space is a treasure trove of resources. It holds rare metals like platinum and gold, as well as other resources like water, which can be used for life support or even fuel in space missions. The possibilities are endless. Space mining could revolutionize industries, power new technologies, and potentially even sustain human life beyond Earth. It's a concept that could fundamentally change how we think about resources and their scarcity. But as with any frontier, there are challenges ahead. Space mining is not just about sending a pickaxe on a rocket. It's an incredibly complex field that combines aspects of engineering, astronomy, economics, and law. Plus, there's the small matter of it being, well, in space. So, as we stand on the precipice of this new era, we must ask ourselves, is space mining the future of resource extraction? Or is it just a pipe dream? A fantasy that will remain confined to the pages of science fiction novels? Space mining could be the next big thing in resource extraction, but it's not without its challenges. Strap in, fellow space enthusiasts, as we journey into the unknown. Imagine if we could tap into the vast wealth of resources in space. Picture a world where we have an almost infinite supply of resources at our disposal, where the environmental impact of mining on Earth is significantly reduced and the costs of space exploration are driven down. This isn't just a sci-fi fantasy, it's the potential reality of space mining. Space mining could provide us with a virtually unlimited supply of resources. Asteroids, comets, and other celestial bodies are filled to the brim with valuable materials. For instance, a single asteroid could contain more platinum than has ever been mined on Earth. Just think about that for a moment. This could mean a world where scarcity of resources is a thing of the past. Imagine the technological advancements that could be made if we had access to such bountiful supplies. Moreover, by shifting mining operations to space, we could significantly reduce the environmental impact of mining on Earth. Mining, as we know it today, is a highly destructive process. It leads to deforestation, soil erosion, and pollution of water bodies. But in space, these negative impacts would be virtually non-existent. The Moon and asteroids don't have ecosystems to disrupt or species to endanger. By moving mining operations off-planet, we could give our Earth a much-needed break. Lastly, space mining could potentially drive down the costs of space exploration. Currently, the cost of launching anything into space is astronomical because every ounce of fuel, food, and equipment must be lifted out of Earth's gravity. However, if we could mine resources directly in space, we could manufacture fuel, build structures, and even grow food there. This could significantly reduce the costs associated with space travel and make the dream of space colonization a more feasible reality. The potential benefits of space mining are truly astronomical, but realizing them is no small task. As we look to the stars for answers, we must also be prepared to meet the challenges that lie ahead. But in the grand scheme of things, the rewards could very well outweigh the risks. After all, the future of humanity may just lie among the stars. However, space mining is far from a done deal. As much as we'd like to revel in the possibilities of this new frontier, it's crucial to remember that the road to space mining is paved with considerable challenges. Before we even consider mining asteroids, we need to tackle the technical difficulties of extracting and transporting resources in space. Imagine trying to drill into an asteroid. The lack of gravity would send both the drill and the asteroid spinning in opposite directions. Not exactly the ideal drilling conditions, is it? And even if we manage to extract the precious metals, how do we transport them back to Earth? Building spacecraft capable of carrying heavy payloads over astronomical distances is no small feat. And then there's the astronomical cost, pun very much intended. Developing the technology, launching missions, and maintaining operations could run into billions, if not trillions of dollars. It's a hefty price tag that not many are willing or able to pay. Yet the potential payoff could be equally astronomical, making it a high-risk, high-reward venture. But the challenges don't stop at technical and financial hurdles. We also need to grapple with legal and ethical issues. Who gets to claim ownership of these space resources? Is it fair for a handful of wealthy corporations to monopolize the riches of space? And what about the potential environmental impact? Could our mining activities inadvertently cause harm to these celestial bodies or even to Earth? These are not easy questions to answer. They require careful consideration and international cooperation. We need to strike a balance between our desire to explore and exploit space resources and our responsibility to protect and preserve the cosmos. Space mining presents a host of challenges that we must overcome if we are to reap its potential benefits. But as we've seen throughout history, humans have an uncanny ability to overcome seemingly insurmountable challenges. And who knows, maybe space mining will be the next big leap for mankind. So, what does the future hold for space mining? As we peer into the future of space mining, we see a realm of possibilities, brimming with potential and fraught with challenges. The present landscape of space mining is quite akin to a chessboard, with countries and companies maneuvering their pieces, vying for the upper hand. Leading the charge in this cosmic game are private companies like SpaceX and Blue Origin, alongside international space agencies such as NASA and the European Space Agency. These entities are investing heavily in technology and research to unlock the mysteries of space and harness its resources. SpaceX, for instance, has been making strides in reusable rocket technology, a development that could significantly cut the cost of space travel. This would make asteroid mining more economically viable, bringing us closer to the goal of sustainable space exploration. Meanwhile, Blue Origin is focusing on lunar landers, which could facilitate the extraction of resources from the moon. Countries are also playing a major role in shaping the future of space mining. The United States, for instance, passed the U.S. Commercial Space Launch Competitiveness Act in 2015, which allows U.S. citizens to own asteroid resources. This legislative move has opened up a new frontier for space entrepreneurship and innovation. Over in Europe, the European Space Agency launched the Hera mission in 2024, aiming to study the composition of asteroids. This could provide valuable insights into the feasibility of asteroid mining. Yet despite these advancements, significant hurdles remain. These range from technological challenges and astronomical costs to legal ambiguities and ethical considerations. But as history has shown us, human ingenuity often thrives in the face of adversity. The companies and countries at the forefront of space mining are not just chasing valuable resources. They're pushing the boundaries of human knowledge and capabilities, rewriting the rules of exploration, and redefining our relationship with space. The future of space mining is uncertain, but one thing is clear: it holds the potential to revolutionize resource extraction and space exploration. In this brief journey, we have explored the potential benefits and challenges of space mining. We've uncovered that the future of mining may not be confined to our blue planet, but could extend to asteroids and other celestial bodies. With the potential to unearth resources like rare metals and water, space mining could revolutionize our economy and advancements in space travel. However, this promising frontier is not without its hurdles. Legal, technical, and environmental challenges loom large. Who owns these celestial bodies? How do we mine in zero-gravity environments? And most importantly, how do we ensure that our cosmic endeavors do not harm the very fabric of space? These are questions that need answers, but one thing is clear. The quest for resources beyond our terrestrial sphere is more than just a dream. It's a tangible prospect that could shape the future of our civilization. Space mining could be the next frontier in resource extraction, but before we can tap into the wealth of the cosmos, we have a universe of challenges to overcome.